This session describes Prim's algorithm. Prim's algorithm constructs a minimum spanning tree through constructing subtrees using already added vertices. For this, we start from an arbitrary vertex. On each iteration, the algorithm expands the current tree in a greedy manner by simply attaching to it the nearest smallest vertex not in that tree. The term greedy means always we are selecting the smallest vertex. The algorithm stops after all the graph's vertices have been included in the tree being constructed. Since the algorithm expands a tree by exactly one vertex on each of its own iterations, the total number of iterations is n minus 1, where n is the number of vertices in the graph. Also, it is important to note that Prim's algorithm always yields a spanning tree, a minimum spanning tree. So, this shows the algorithm. The input is a weighted connected graph G, which is the ordered pair VE, which describes the set of vertices and edges. Output is E of t, where it is a set of edges composing a minimum spanning tree of G. So, in this algorithm, we start with V of two sets, V of t and E of t, where V of t is set of vertices and E of t is the set of edges. Initially, we can start from any of the vertex. So, here we can start from A, and currently the edges are, we do not have any edges. So, edges, set of edges is a null set. Null set means a set with no elements. Then we have a loop. So, what we are doing is, we are iterating this for each vertex. Here we have 5 vertices. So, in our case, our V of t equal to vertex V of t equal to vertex A, and E of t is a null set, which means that we do not have any elements. So, the next step is, we will be finding an edge with the minimum weight starting from A. So, you can have this one, this one, this one, or this one. So, the edge with the minimum weight is this edge AB, which is having the weight 3. So, we will be adding, we will be selecting the vertex B and adding it to V of t. V of t will become A and B, and edge B selected is AB, the one with the minimum weight starting from A, AB. So, our tree will be like vertex A, vertex B, the edge weight with the edge weight 3. So, next is, we have two choices A and B. So, we will be looking at all the edges starting from both A and B. So, we can consider this one with the weight 9, this one with the 6, this one with the 7. There is no need to consider this one, which means that since this is already added, then from B we can consider this. So, among these 4, the one with the minimum weight is BC with the weight 5. So, you can add C, you can add C to the vertex list and you can select the edge BC. So you can select edge BC. So our edge will be like BC with the edge weight 5. So now we have 3 choices. So from these 3 choices, again we will be selecting the one with the smallest weight. So if you consider this, the one with the smallest weight is you can have this one, this one, this one, and this one with 3, which is already selected. So the choices are 8, 7, 6, 8, 7, 6, and A, which is of the weight 9. So the smallest one is one with weight 6, that connects A to D. So we will be selecting D. We will be adding the edge AD. We will be adding the edge AD, and the edge added is A to D. A to D with the weight 6. So we have 4 choices, and this is our last iteration. You need to select the next vertex. So you can have D. From D we have one edge 4, AD 6, A we have one A9. We can see that the one with the smallest edge weight, which does not form a cycle. We also need to look at the fact that they should not form a cycle. Cycle means a closed loop. So here you can see that this does not, if you select D, this does not form a cycle. So this can be selected DE, and the edge is DE. So this completes the algorithm, and the edge is DE with edge weight 4. All the iterations are completed. So these are the vertices, and these are the edges. These are the vertices, and these are the edges. And this forms a minimum cost spanning tree, minimum spanning tree. You can see that the edge weights are 3 plus 5 plus 6 plus 4, that is 18. There are many spanning trees possible, and Prim's algorithm will give you the one with the minimum cost, that is the cost of 18.